Here's what I would like you to do. We're just going to go through this chapter test that I have in this book that you don't have. Well, you have an e-version. So we're just going to go problem by problem. We'll do this for about 15 minutes or so, and then I'll give you the grace of letting you out a little early and releasing you from my presence. Okay, so do problem 1. We're just going back to the very beginning. We're getting ready for the test. Oh, you can't see in the class. Woo! Okay, problem 1, please. Oh, and the answer's there. Oh. Well, I guess you know what you're looking for then. We'll have to fix that. Now that you've already seen it, if you're watching the video, you know, but that's okay. We'll take care of this. Aha, you will not see any of my answers. Aha. Okay, well, since the surprise is spoiled on this particular problem, let's go ahead and get it out of the way, just in case you don't know. This is just a basic empirical probability problem. It's empirical probability, remember, because according to the problem, something has actually been surveyed or experimented on. So for problem 1 right here, what we see is that the last 25 people who purchased a donut at Dunkin' Donuts, donuts sound really good today, this morning too, 11 purchased a glazed donut. Determine the empirical probability that the next person who purchases a donut purchases a glaze, so the probability of a glazed donut, and we all saw the surprise. There were 11 people that agreed with that outcome out of 25 total, and then we always obey what we're told to. So on the test, I don't care. You're going to do one of two things for me with probability. You're going to either leave it as a reduced fraction, which in this case would be less work, or if you do pop it into your calculator, you're going to round to the 4th decimal place. This one is a terminating decimal. It's going to be 0.44, so you don't have to round it all. But if you do get a long string of numbers, you're going to round to the 4th decimal place for me. That gives me some good accuracy. Is there any questions about that problem before we go on to the next problem? All right, then here's what I would like you to do. Each of the numbers 1 through 9 is written on a sheet of paper, and the 9 sheets of paper are placed in a hat, very specific. If one sheet of paper is randomly selected from the hat, determine the probability that the number selected is greater than 5. Okay, so you go ahead and do that problem for me, greater than 5. All right, probability greater than 5. What's the numerator of this going to be? I'm sorry? I didn't hear what you said. 9? Well, the numerator is not going to be 9, but the denominator, I'll agree with you, is 9, because there's 9 total outcomes I can have. How many of them agree with this event, though, of being greater than 5? 4 of them. So it's 4 out of 9, and that's a reduced fraction. So I am not going to do any other work. Any question, comment, concern about that problem? I do the next one. What's the probability that the number you pick is odd? Okay, looks like most of you are done with that, so here we go. How many outcomes agree with odd? 1, 3, 5, 7, 9, so that is 5 total out of the 9. So there is my probability, 5 times out of 9. I'm going to get an odd problem. Here is another problem. What's the probability that you select an even number or a number less than 4? right, here's a great opportunity to review OR problems. Okay, so we're selecting one thing. I want to know what's the probability of the even or less than 4. So remember, the way we do this is we say, okay, what's the probability of an even number plus the probability that the number is less than 4. Then what I have to do is I have to subtract out any duplicates. So I have to subtract out the probability that something is even and less than 4. Sorry, there's a different ratio on the computer screen up here than there is on the screen over there. So on the computer screen, it's all on there and I got so much extra room, but up there it's not. So sorry, I will do better for you. You deserve much better than that. Okay, so this is the OR event. So this is good to remember. So now we can break it up into these simple events. So the probability that I pick an even number is, so we got 2, 4, 6, or 8. Who do we appreciate? There we go, the Perkster. 4 out of 9. The probability it's less than 4 is 1, 2, 3. So 3 out of 9. And then how many numbers are both even and less than 4? Well, that would just be the number 2. So that happened. We counted the number 2 twice. We counted the number 2 when we counted even numbers. We counted the number 2 when we counted numbers less than 4. So we've double counted. And so that's what we have to do here. By the way, does anyone remember what it's called when I have two events that this probability here of them happening together is 0? What's the probability, or what is it called when two events cannot happen at the same time? I'm sorry? I just didn't hear what you said. It is impossible. The probability is 0. Yes, better. Oh. The screen just asked me. You can't see this because I'm projecting directly from the camera to there, but going to Zoom, it says when I did mute, it asked me, "Are you playing music?" Probably for copyright violation. I don't know what song that could possibly have sounded like, but great, thank you. Okay, so I'm sorry, I'm way more entertained than you. I understand, I am not that entertaining. 4 plus 3 is 7, minus 1 is 6 out of 9, and I'm gonna reduce that to 3 goes into 6 twice, 3 goes into 9 3 times. Okay, so that's probably the first more difficult problem we've done. Anybody got a question about that OR problem? Anything I need to elaborate on because I did not do a good job with it. Okay, so next one, we're going to have a new type of problem. It says if two, okay, so now we're doing a different kind of event. If 2 of the same 9 sheets of paper mentioned above are selected, so we're still referring to what was up above. Without replacement, ooh, that's fun. Determine the probability that both numbers are less than 3. Okay, so what we're doing is we're selecting 2 numbers from the hat without replacement. What's the probability that both are less than 3? Without replacement, yes. So remember, this is an AND event. The big way I know this is an AND event is I'm doing 2 things now. I have 2 trials. So when I'm finding the probability of both are less than 3, what I want to know is what's the probability the first one is less than 3, and then the probability the second one is less than 3. So we multiply these probabilities together. So without replacement is significant here. So that means what's the probability the first one is less than 3? The probability the first of these numbers I draw. Okay, there are 2 numbers less than 3 out of 9. Yes. Now we're doing this without replacement. We're not, whatever piece of paper I pull out, I am throwing to the side. So now the second time, how many numbers less than 3 are there the second time? 1 out of how many numbers? Perfect. Well done. And so that is 2 out of 72. And when I reduce that, that's 1 out of 36. 1 chance out of 36. Yeah. I think what they meant by that is now we're picking 2 out of the 9 sheets of paper. There, we didn't put 2 of the same of each of them in the bag. I can see how that's kind of a little bit of a weird wording, but no, what they're implying there is I'm pulling 2 of those 9 sheets of paper out of the hat. All right, we'll give number 6 a try then. It's the same sort of thing. So if you forgot about your and events, you get another try at it. Again, we're doing this without replacement. So this time we're asked what's the probability the first one is odd and then the second one is even. So the probability of an odd and an even. So this is the probability of an odd, and then we're going to multiply times the probability of an even number. So the probability of an odd, I think we already calculated that. The probability of an odd, there are 5 odd numbers out of the 9. And now we're doing this again without replacement. So when I do this without replacement, how many even numbers are left in the hat? 4. There was only 4 to begin with, and I haven't pulled one out, so there's still 4. Out of how many scraps of paper are in the hat? 8, because I did the first one without replacing it. So here we go. So that actually is 1/2. Let me write that down. I'm going to reduce first on this one. And so now when I multiply that together, 5 times 1 is 5. 9 times 2 is 18. That will happen 5 out of 18 times. Great. All right, we're going to go to, we're not going to do number 7. We're going to go up to the top of the next column here. We're going to remind ourselves, just in case you didn't do great with the first OR problem, we're going to do the next OR problem right here. So go ahead and do problem number 8 at the top of that column. Oh, sorry. It was 5/9 times 4/8. And then I reduced the 4/8 to 1/2 to make the numbers easier to multiply because I don't have my calculator in front of me. So I'm just using fractions. And then you multiply by doing tops and bottoms. So 5 times 1 gave me 5. 9 times 2 gave me 18. So 5 out of 18. Okay. Yep, no problem. Thank you for asking. Never let me move on if I've confused you. What's that? Sure, go ahead. I'll grab my calculator. I'll stop being lazy. Okay, so this one says we're selecting a card randomly from a 52 card deck. What's the probability that the card is red or a face card? So we want the probability that it's red or a face card. So this is another OR problem like we did previously. I just want to make sure that we're reviewing it adequately. So for any OR problem, we're going to do what's the probability of the first event, so probability of red, plus the probability of the second event, face, and then minus the probability that those two things happen together. So the probability that's red and a face card. Okay, great. So here we go. How many red cards are there in the deck of cards? There are 52 cards total, so we'll put that, but out of those, how many of them are red? 26. Okay, I will ask some card problems on the test, but I will have a picture of the deck of cards projected for you. I don't want you to stress about that. Okay, plus the probability of a face card. How many face cards? Do you remember how many face cards there are in the deck? Yeah, there's 3 of each. There's a jack, a queen, a king of each suit, so there's 12 out of 52. But we've double counted some. These are not mutually exclusive events. How many red face cards are there? There's 3 hearts, there's 3 diamonds. So there's going to be 6 out of 52. Remember, it's the jack, the queen, the king. Those are the only 3 face cards in the deck. And so there's 3 in the diamonds, there's 3 in the clubs. And so now I add those numbers together, 26 and 12, that is 38. Minus 6 is 32 out of 52. If you chose to reduce this fraction, 4 goes into 32 8 times, 4 goes into 52 13 times. If you chose to give me a 4-digit decimal, then what you gave me is 8 divided by 13, and you told me that that was about 0.6154. Or about a 61.5% chance that that's going to happen. Okay, just because of time's sake, I'm going to skip ahead. We're not that these next things aren't important, tree diagrams and such. I just wanted to go to just one other thing. I have one thing in mind that I wanted to do. So the last thing we're going to do here is this. And then I'm going to give you the gift of a couple of minutes of time early today. I'm a math teacher and we don't naturally like to do that, but you guys are a good class. So, okay, so let's see, I gotta zoom back a little bit to get everything I want on the screen. So what we're going to do is problem 17. Oh, okay, it's doing it up there, but not on my screen. Okay, we're gonna do problem 17 and there's 4 parts to it. So the table for problem 17 is down here. So it's the number of cars and SUVs using a particular bridge. And then we're going to do, I want you to do these 4 problems up here. There's 2 normal probability problems and there's 2 conditional probability problems that I'm asking you to do. All right, so here goes. Let's see how this works. We'll give some decimal answers. We'll have a great time, and then that'll be it. So here we go. So what's the first thing? It says, what's the probability that the car that I pick is actually an SUV? So I guess the vehicle that I pick. So we're just practicing reading the table here. How many SUVs are we talking about? 242 out of how many total vehicles? 456. Now you can reduce that if you want, but I'm going to go ahead 242. Whoops, how about if I hit all the numbers? 242 divided by 456. And to 4 decimal places, that's 0.5307. The next one is, again, another straightforward probability problem. What's the probability that it's going through the George Washington Bridge? So I'm just going to abbreviate that, the GW. Okay, so how many cars went through the George Washington Bridge? Or how many vehicles went through the George Washington Bridge? 226 out of, again, 456 vehicles that I have been monitoring here. So 226 divided by 456 to 4 decimal places, that's 0.4956. The next problem says, what's the probability that it's an SUV, but this time we've got some given information, given that it went through the George Washington Bridge. So remember, when we do conditional probability, the condition becomes our new total number of outcomes. So I've just covered up the table because my piece of paper is rather large here, so I'm going to uncover it. So according to the table, my given information, how many people went through the George Washington Bridge? 226. So that 226 becomes the denominator of my fraction. Okay, so I'm only looking at that. So when I come over here to my table now, I'm only considering this row for the George Washington Bridge. And out of that row for the George Washington Bridge, how many SUVs do we have that went over it? 106. So those are the numbers that you're going to use for this conditional probability problem. I know conditional probability can be a little bit testy. So if you have an issue or a question, please raise it so that we can get it out of the way. So 0.4690 is the result there. All right, the last one says, what's the probability that it is going through a toll gate at the George Washington Bridge, given that it is a car? Golden Gate, yes, I'm not wearing my glasses, so you can tell. Golden Gate Bridge. Thank you for being here and correcting me. It's always humiliating, but I appreciate it. Okay, so going back to my table, how many cars do I have in my table? 214, yes, so 214, so that's going to be the denominator. And now I'm just looking over at the table now. I'm just looking at this column because that's the given information. I'm only caring about the cars and how many of them are going over to the Golden Gate Bridge. 94 of them. And so when I divide that out, 94 divided by 214 is 0.4393. And there we go. And that's just a quick little review of just some concepts. That is not an exhaustive review. So don't think those are the only things on the test. I just wanted to go over some things because this is a long unit that we talked about a while ago.